Good day to everyone. Today's topic is heap sort. The task is explain step by heap sort, show both tree view and array view. Heap sort is a comparison-based sorting algorithm that uses a binary heap data structure to sort elements. And first, we have our array view, and the tree view. Array view represents the elements of the array in a linear fashion. Each element of the array is placed at a specific index, starting from index 0. You can visualize the array view as a horizontal list of elements. And the tree view represents the elements of the array in hierarchical tree structure in a binary heap. Each element of the array corresponds to a node in the tree. The root of the tree corresponds to the first element of the array. For any node in index I in the array, its left child is at index 2 multiplied by I plus 1, and its right child is at index 2 multiplied by 1 and plus 2. This is the structure of this tree view. Okay. We have our array view and tree view. The next, we have to convert the input array into max heap, starting from the last non-leaf node and moving up to the root. Heapify each subtrees to maintain the max heap properly. Okay, the second step, we have to repeat these following steps until the heap size is 1, and swap the root with the last element of the heap and reduce the heap size by 1. Okay, and this our final result. It's all these steps, and this blue one is the final result. This array was sorted. 1, 2, 3, 5, 8, 4. Okay, I think that's not correct final answer. And this is our tree view and how this was complicated. And from this, the array is now sorted in an ascending order, and final sorted array is 1, 2, 3, 4, 5, 6, 8, and 10. This is a basic overview of how heap sort works, and I want to explain this by code. So firstly, I want to check the final result again. Yes, that's true. 1, 2, 3, 4, 5, 6, 8, and 10. This how works this array view and tree view in the code. I will explain it. Okay, the first one, I want to stop in the heapify function. Heapify function takes an array R, its size n, and index I as input. It heapifies the subtree rooted at I to maintain the max heap properly. It compares the parent node with its children and, if necessary, swaps the parent with the largest child and recursively calls itself on the swapped child. Yes. And the heap sort, this heap sort method function, or this method takes an array R as input and performs heap sort on it. It first builds a max heap from the input array by calling heapify on each non-leaf node, starting from the last non-leaf node to the root. Then it repeatedly extracts the maximum element from the heap and heapifies the remaining heap. Okay, so two methods, and this print array that prints, and main array, main method. And there is step by step array explaining. We building max heap in our sort method and extract the elements from heap one by one, move current root to end, and call max heapify. Okay, I explained it. Then we printed array driver method. The result is like this. And this implementation demonstrates the entire process of heap sort, from building the max heap to extracting elements to get a sorted array. I hope that I understand, I explained it very simple, and I explained the first array view, tree view, explained every method and every step of this. And in summary, the array view shows the elements of the array in a linear format, while the tree view represents the elements in a hierarchical tree structure. So it's the end, and I hope I will have 100 because I explained this array view, tree view, and explained step by step this heap sort as in the exercise, our task. Yes, and our input size is 4 and it's unsorted. That's all.